My talk on sort of microservices in general with some example Scala code and some example Java code. So a little bit about me. If you don't know me, I'm Chris Richardson. I live across the bay in Oakland. I got my start in programming back in the late 80s building Lisp systems. So runtimes, garbage collectors, all the way up the stack to quite sophisticated IDEs. And then back in 2006, my book Pojos in Action came out. Maybe I'll stand over here. Came out, and that was all about building applications with Spring and Hibernate. And then back in 2007, I started tinkering with Amazon EC2, which back then was an extremely obscure service. Like, it had just got started. But the concept of being able to provision 20 servers and pay just 10 cents per hour per server just blew my mind. So I ended up creating an open source project which evolved into a platform as a service for Java called Cloud Foundry, which was then acquired by SpringSource shortly before SpringSource was acquired by VMware. So told this joke on Tuesday, so apologies to the people who heard it before. But I'd like to say that this is not drawn to scale in terms of market cap. Otherwise, I would be multi-billionaire by now. Cloud Foundry was much more of a plankton than a fish. Anyway, so I was there for 4+ years. These days, I do everything related to microservices, consulting and training. I'm actually teaching a public class in Oakland, on one-day class, April 28th, if anyone's interested in having an in-depth look at microservices. And I'm also the founder of a startup that's a platform that makes it easy to write event-driven microservices. So that's called eventuate.io. Not to be confused with a GitHub project in the Scala community with the same name. And if you want to have more information, then just fill in the form here, and I'll send you a bunch of links that are relevant to this talk. So events March 17th. OK, so the agenda, I want to begin with just a sort of philosophical discussion about why one of the projects that I've been working on is a pattern language for microservices. Talk very briefly about microservice architecture versus monolithic architecture. I don't want to sort of rehash the intro argument too much. And then just dig into event-driven applications with event sourcing and CQRS, and look at some code examples. And then if there's time, I'll show a short video of an interesting application that we recently built. OK, so why a pattern language for microservices? So 30 years ago, Fred Brooks, famous computer scientist, well known for the mythical Man Month, said that there are no silver bullets in software engineering. So in other words, there's no technology that if you adopted will give you a 10x boost in productivity. I mean, there's actually a whole bunch of things that if you do will slow you down by that order of magnitude. But there really aren't these silver bullets. Yet 30 years later, developers are passionately arguing about their favorite technology, absolutely convinced that if you adopt it, everything will be unicorns and rainbows. And you often see arguments like this, especially on Twitter. It's like, if you do X, a puppy will die, or a kitten. Therefore, you must. Just to get a sense, I've sort of created this little quiz where you can match up things on the left with things on the right. I'll leave that as an exercise for later. But there's a tremendous amount of discussions like this where this is really bad and you have to do this. And the underlying reason for a lot of this just sort of hype within our community is that we as human beings are basically emotional beings, right? So cognitive psychologists like to use this metaphor of an elephant and a rider. So the elephant represents the emotional part of our brain. That's how we make decisions, basically using emotions. And the rider represents the sort of the rational part of our brain, which tries to influence the elephant, but really the elephant does exactly what it wants. And the rider basically comes up with logical sounding justifications for why you've come to some decision emotionally. So if you take this model of human behavior, it explains an awful lot about technology adoption and decision making. Also on a broader scale, why Donald Trump is doing well. It really does. So the actual, and also some of the other candidates as well, but yeah, there's actually this book, Righteous Minds, Why Good People Are Divided by Religion and Politics, by a cognitive psychologist, and it explains reality remarkably well. But you know, as engineers, we need a better way of making decisions, right? To something to overcome our sort of emotional infrastructure. And for me, one really useful tool that you can use to describe technology is the idea of a pattern, or a software pattern, design pattern. You know, an idea that itself is 20+ years old and went through its own hype cycle. But the actual structure of a pattern provides a really, really good format for discussing technology. So you have, you know, obviously a pattern has a name that describes it. It has a context, which is really, really relevant, right? So solving a problem using one solution in one context makes sense, but perhaps in a different context, maybe a different solution would be more appropriate. So you think about today, much of the thought leadership is by companies who are operating at extremely high volume. Netflix, Facebook, Twitter, and so on. And maybe if you're building a lower scale application, then perhaps some of their stuff is not the best approach. Just to throw out an example. There's a problem that you're trying to solve. There's forces, which are the issues that you're trying to address. And then obviously there's the solution, right? You know, that's the whole point of the pattern. And then there are two really interesting parts to the pattern, one of which is the resulting context. What happens when you apply this pattern? So that says, well, here are the benefits, here are the forces that have been resolved, but also here are the drawbacks, here are the forces that have been left unresolved by the solution, plus there are issues. What are the new problems that applying this pattern have actually introduced? So, you know, just to pick an example, right, like reactive programming is all the rage, yet code understandability and debuggability suffers quite a lot in a reactive architecture, right? So that even though it's high performance, there's distinctly trade-offs. And then there's also related patterns. So these are either patterns that provide an alternative solution to the same problem, or these are patterns that solve problems that have been introduced by applying this pattern. So the pattern just kind of points you through the solution space and helps you solve a problem or apply a particular technology. So that's sort of philosophical discussion. So one of the things that I've been working on for the past 18 months or so is a pattern language for microservices. So if you go to microservices.io, you will see this, and it's a collection of patterns that can help you apply microservices. Well, first off, decide whether you should be applying microservices, and then if you are, how to apply them. So there are the core patterns, monolith versus microservice architecture. There are various infrastructure patterns, such as how do you deploy your microservices? Do you run many of them on a single machine? Do you use a microservice per container, a microservice per VM? Then because you're building a distributed system, there's a whole host of communication-related patterns, different styles of inter-process communication, service discovery, sort of the API gateway, how do components, clients of the system interact with the system, which is now made up of microservices. There's the microservice chassis, a framework upon which you build your microservices. And then, which is really what I'm going to talk about today, is a set of application patterns, which are all concerned with data. And in particular, maintaining data consistency in a microservice architecture. And this is very much work in progress. Every so often, I add new patterns. So that's the pattern language. Go to microservices.io to learn more. So I'm going to talk a little bit about the monolithic architecture versus microservice architecture. I mean, I think, we all pretty much have heard kind of why microservices are fantastic. We've also heard why microservices are not so great, namely the complexity. But I kind of wanted to make a couple of quick points. So in theory, right, you could build a modular monolithic application which gives you many of the benefits of a microservice architecture. But in practice, I think most monolithic applications end up as a big ball of mud, right? I mean, I think there's a certain inevitability that you write some code or write an app, that application is just going to get bigger, the quality of the design is going to degrade, it's just going to be a lot of tangled dependencies, and you're going to end up in a very painful place where any notion of agile development and deployment is next to impossible. So in theory, you can, but I think in practice it's extremely difficult. So that means that for most large, complex applications, microservices, which for many reasons are not a silver bullet, tend to be the right choice for those large, complex applications. I don't know what large or complex actually means. For some people, that could be 1 million lines of code. But I did hear a talk about one company around here who had 75,000 lines of C#, 15 developers. So it was kind of a tiny application, but their whole development and release cycle was sped up by an order of magnitude by migrating to a microservice architecture. So it is very context specific. But in general, the big benefit is that it lets you build better software faster, right? Or build and deliver. So you as a developer can program more productively. The tempo of your releases goes from quarterly down to, hopefully, many times a day. And then also, I think another thing that's really worth pointing out, I think a key benefit of the microservice architecture is that it enables you to try out new technology. Now, I know, I very much live in the Java world, or the JVM world, I should say. And this is a Scala meetup, so I'm sure everyone here is a big fan of Scala, despite the slow compilation times. But there are other technologies out there, right? Node is a good candidate for some microservices. Golang is another alternative, Clojure, and so on. Even Python, possibly. So one of the nice things about the microservice architecture is it really does let you experiment with new technologies and fail safely. So, you can sort of view going forward, we're going to be in increasingly a polyglot persistence, a polyglot world where we're using a mixture of languages. I guess we're using a mixture of databases as well. There's very similar arguments that apply there. So that's my brief commentary on basic microservices. And I just want to talk about event sourcing and event-driven architecture. So there's a whole set of patterns, starting off with database architecture and going into event-driven architecture, and then various ways of implementing an event-driven architecture. So one of the key patterns in the microservice architecture is a database per service, which is a slightly inaccurate term. What it means is that the data, each microservice owns data. That data is private to it. It doesn't necessarily mean that it's an entire database server per microservice. It could just be private tables, a private schema, or possibly a private server. There's lots of options. And in a way, the shared database pattern, because of the coupling that it introduces between services, can be considered an anti-pattern rather than a sort of legitimate pattern. So you want to really go with the database per service approach, right? So if you're dealing with orders and customers, the order service has its order database, the customer service has its customer database. They could very well be implemented using different technologies. One could be relational, another one could be Mongo, a third could be Neo4j. So it's sort of this polyglot persistence, functionally decomposed database world. But one of the problems that introduces is how to maintain data consistency across these multiple databases. So if you think about it, that's what we use ACID transactions for, right? So in this example, customers have a credit limit. So that means that when we create a new order, we need to verify that that new order will not exceed a credit limit. If both orders and customers were within the same database, you could accomplish that fairly straightforwardly by using a transaction with the right isolation level. And so it can enforce this invariant. But in a microservice architecture, it's partitioned. So orders in one database and customers in the other. So it's sort of like, how do we maintain those invariants? Now we can't, for a whole bunch of reasons, we cannot use two-phase commit. And so that leads you in the direction of, having an event-driven architecture. So the idea is that when state changes in one service, it publishes an event. An order has been created. That would get consumed by the customer service, which would perform the credit check and then publish an event indicating the outcome of that credit check. And the order service would receive that event and update the state of the order to approved if the credit check was approved, canceled if the credit check was rejected. So, I first read about this approach, I think 10 plus years ago, in an article by eBay. So they had functionally decomposed their databases, and even though they were relational, they still used an event-driven approach as opposed to distributed transactions. But that introduces a problem. How do you atomically update state and publish an event? The traditional solution to that, of course, is two-phase commit, right, where both the message broker and the database participate in that same transaction. But that's exactly the kind of approach that we're trying to avoid. So there's several different ways of reliably, sort of atomically and reliably updating state and publishing an event. So the application can actually insert events into an event table as part of that local transaction. You could use database triggers. That could work as well. You could tail the transaction log because that is the source of truth in the system. But then the approach that I'm and there's actually various trade-offs with each one of those approaches that some of which I wrote up in an article on the Nginx blog. And then there's event sourcing, which is sort of my preferred approach. And the big idea behind event sourcing, I'm sure some of you are familiar with that in the context of Akka persistence. But the idea with event sourcing is instead of, say, taking an order, mapping it to an order table or a row within the order table, instead what you do is store the sequence of state-changing events. So when an order is created, you save an event, order created event. When it's approved, you insert another event. When it's shipped, and so on. So you're actually storing in the database the sequence of state changes. And then when it's time, when you need to reconstruct the current state of the order, you just load those events and basically do a functional fold to reconstruct the current state of the order. And in order to optimize it, you might use the notion of snapshots as well. So you periodically snapshot, and then you only have to, you find the most recent event, most recent snapshot, and replay the events that have occurred since then. So that's kind of the essence of event sourcing at a super duper high level. But one question you have is, well, what about queries? So if you suppose for a minute that the events are stored in an event table inside Postgres, some people actually do that, you could write queries to say, find all of the bank accounts whose balance is greater than X, right? In theory, you could write a query to do that, which would somehow in SQL have to do the functional fold of the events for each aggregate. You probably really don't want to do that. It gets complicated and inefficient very quickly. So that's where another pattern comes into play, command query responsibility segregation. And the idea here is that you split your system into two parts. You have the command side, which handles updates, or creates and updates and deletes. So in other words, HTTP posts, puts, and deletes. And then you have the query side that handles queries. In other words, HTTP gets. And those two parts of the application, which have separate data stores, are kept in sync by the query side subscribing to events that are published by the command side. So as the name suggests, it's really separation of responsibilities. So the query side gets these events. It can update a materialized view. So in terms of microservices, it could look like this. So you have a view, which could be MongoDB, right? Because that's like good JSON storage for supporting a REST API in a web scale way. It could be Neo4j because you need to do graph queries on a social graph. Or it could be Elasticsearch because you want to do text queries. So you pick the kind of view to support the queries that you want to execute. You then have a service that subscribes to the events and is responsible for updating the view. You have another service that handles the HTTP GET and queries the database, queries the view, and retrieves the data. So that's sort of the piece. So putting them together, you end up with an architecture that looks like this. The font's a little small. So you have microservices that play the role for the command side that host domain-driven design aggregates that are persisted using event sourcing. You have a view query module view module that's updating the data store and another component that's handling the gets. You might also have other services that are subscribing to the event store and sending out notifications, email, Twilio, text messages, and so on. And so the product I'm building is basically an event store that supports this model, and then it's got one or more client-side frameworks that are language and framework specific. So today I was going to show the Java flavor and one of the Scala flavors of those client frameworks. So yeah, there's actually different flavors. So there's sort of a traditional Java model that's got mutable domain objects. So just fields that are just set in the traditional Java way. And then I also have a couple of different functional Scala models. One that's sort of hybrid OOFP, and then the other one that's more hardcore FP using type classes. And I guess like if you were at my Scala by the Bay talks last year and the year before, I might have talked about, I think I did talk about both these models. So let's quickly look at the Java version, the one that mutates state and kills kittens. So we're going to look at the customer aggregate. So customer in this simplified model has a credit limit, which is money, and credit reservations that's a map from order ID to the order total. So saying this order is reserving this much of the credit. The actual business logic is implemented by process methods that take a command. So that's a command to perform an update. And they return a list of events. Then there are apply event methods that take an event and do an in-place state mutation. So just modify the customer state in some way. So that's sort of the model. And if you think about it, right, so business logic has this very stylized form of process methods that take commands, give you events, and apply methods that do the state update, return, avoid. And what's basically happened here is that a sort of traditional style business logic method like reserve credit, which is doing two things, sort of performing validation and mutating state, has really just been split into two parts. The command processing that's doing the verification, the validation, and it returns an event which then when it's applied does the state update. So it's sort of the same kind of business logic, but just split into two parts. And the reason you need the apply method, obviously, is so that you can reinitialize the current state when you load the events from the database. So, normal kind of processing is you instantiate an object using its default constructor, take the list of events, basically fold it, calling apply over and over again with each event. So here's some code. So it actually, it's not a complete POJO just yet. Kind of working on it. So it actually implements reflective mutable command processing aggregate, which makes sense, right? It's an aggregate, so it's got an apply event method. It processes commands, right? It's mutable because it's doing an in-place state update as opposed to returning a copy. And it's reflective because it's using reflection to look up the appropriate process and apply methods based on the type of the command or the event that you're processing. So it's quite logical. Which reminds me, it's sort of the whole joke about Spring, right? Abstract, factory, decorator, doodad, command class, right? But anyway, so like here's the process method. So the first one is really, processing a create customer command. It just returns back a customer created event, so nothing much going on there. The reserve credit command, the process method that processes a reserve credit command actually has some business logic, right? It's saying if the available credit is greater than or equal to the order total, then we have successfully reserved credit, or we can successfully reserve credit. So we're going to return a customer credit reserved event. Otherwise, we've exceeded the credit limit, and we're going to return a customer credit limit exceeded event. So it's conditional logic, right? So then there's apply methods. They're fairly straightforward. They're just taking data out of the event and updating state. So the one that's interesting is the customer credit reserved event, where it's inserting an entry into the map to say this order has reserved this much credit. The other one doesn't represent a state change. It's just sort of signaling that something important has happened, which is not a state change. So that's what an aggregate looks like. And if this causes you distress, just hold on a little while, and I'll show you some nice functional code in a little bit. Here's a service that's creating an order. And it's written in terms of this helper class aggregate repository. And that has a save method that says save. It just says, here's a command. And under the covers, what it's doing is actually instantiating a whole new order, processing the command which yields events, applying those events to do the state change, and then saving those events in the event store, and it actually returns back the updated aggregate. And no, I'm using RxJava because Java futures mostly suck. So it's sort of written in a somewhat reactive style. So that's what a service method looks like. This one's creating a new order. And here's an example of an event handler. It handles the order created event and finds the appropriate customer and attempts to reserve the credit. And it actually gets past this event handler context that's sort of like an envelope that contains the event, and it also provides an update method that says, go find this customer with this ID and process this command. And under the covers, it's actually interacting with the event store, loading the customer, processing the command, applying the events, and saving the events back into the event store. Oh, and it's written using, oh my God, Spring. So the @event subscriber annotation is actually picked up by a Spring Bean post-processor, which automatically registers that, automatically subscribes it to the event store using the event store's Stomp API. So, so this style of API is using a bunch of reflection, and one could easily imagine the non-Spring version sort of being more sort of, you would write code rather than rely on this sort of reflective capability. Oh yeah, and in the query side, you really need to support many different kinds of views. And so this particular view, I'm storing a customer and their recent orders as a document in MongoDB. So in order to display this, that's just one primary key lookup in Mongo, and you get a blob of JSON that can be returned through the REST API to the browser client. So that's quite nice. And here's an event handler that's subscribing to all of the customer and order events and updating the corresponding document. There's a bunch of details here. I mean, the actual code itself is implemented using Spring Data for MongoDB, which provides a nice high-level abstraction over the Mongo database. But you could imagine doing exactly the same thing with Cassandra, with Neo4j, with Redis, whatever database makes sense for your particular kind of queries. I've also heard that Postgres outperforms Mongo when it comes to JSON, so that might be another candidate as well, which is really funny. OK, so that's that. Let's look at the nice immutable Scala version. So it's functional in style, so means there's a separation of concerns. There's the immutable state representing the customer, the credit limit, and the credit reservations. And then there's the customer aggregate that's got these process command methods or a process method that takes or actually should take a customer and a command and gives you back events, and then an apply event method that takes a customer and gives you back a customer. I don't know how many times I've stared at that slide and not noticed that typo. So it's implemented using type classes, and there's a couple of sort of which are represented by a couple of traits. So there's a concept of an aggregate that knows how to you can create an instance of the type. There's also, and that's actually used by the event store to reconstruct the current state of an aggregate. One of the interesting things is that the aggregate event is just defined as an abstract type member at this point. And then it's got apply event methods and apply events that's doing the fold. And then there's a trait that extends this and adds command processing functionality, the process command method. And that, once again, that's got an abstract type member for the type of the command. So I was not able to express that cleanly in the Java version, or at least I didn't try hard enough to express it cleanly. But some of these sort of more advanced features in Scala mean that you can express the typing a lot better. And if the command processing fails, I'm using a try. So it's either an exception or it's a sequence of events. So here's the actual module, customer aggregate module. So there's some business logic in here, like for calculating credit and so on. So just some basically functions in there that manipulate the customer state. And here's the concrete type class. So it's a command processing aggregate of type customer. Define the concrete types for the commands and the events. Concrete implementation of the new instance method that creates a blank customer. And then the process method just relies on Scala's lovely pattern matching capabilities, so I don't need to sort of use reflection to look up, to dispatch the command. So that's quite nice. And then likewise, the apply event method relies on pattern matching as well to actually dispatch on the event type as well. And because the state is a case class, can just copy and modify it using the built-in copy method. So it's actually kind of a lot cleaner than the Java version. But it's important to remember that these are just different flavors of framework that are sitting on top of the same underlying platform. So you get to pick whatever makes sense to you. All right, so that's the Java Scala version. Remarkably, I am almost on time, which rarely happens. So I want to finish up with just a really simple talk about another demo I'm excited about because it's visual. A lot of the demos I've written just have a REST API, and you actually have to interact them using curl. This one has a fairly decent UI. Though this is not the best screenshot. But the idea is it's a Kanban board, and so you can create boards, and then when you're in a board, you can create tasks, which you can then drag and drop between columns. And what's particularly nice about this is that it's collaborative. So multiple people could be viewing the same board, and the application is actually subscribing to events that are coming out of the event store, translating them into WebSockets, and pushing them down to the browser, which is just kind of cool, really. So architecturally, it looks like this. So you've got an Angular JS application in the browser. The server has a REST API for CRUD operations on boards and tasks, basically, and actually retrieving them as well. And what's actually interesting, the server has a microservice architecture. So even though here I've drawn it as a monolith, there's actually like 5 different services fronted by an API gateway. So if you go to the GitHub repo, you will see all of this code and its wonderful complexity. It uses WebSockets to push events from the event store down to the browser. It's using the eventuate event store to store the boards and the tasks. And it's also using MongoDB as a materialized view. So there's kind of a lot going on, but the end result looks actually quite decent. So this is a little video. I think I recorded this in my hotel room in Sweden. So it's actually running on my laptop, talking to an event store that's running in the AWS Northern California region. And the performance was not bad. I actually tried to do this on the flight home as well. And United Wi-Fi has really high latency. It actually uncovered a couple of bugs in the Angular code that you would never, ever have seen on a high-performance network. So let's see if we can make this play. So I'm just going to create a board. Whoa. Whoa, this is cool. You can hear me. I wonder if you can hear me curse when I make a typo as well. OK, so I created a board, and it actually updated in 2 places. And because this was on my laptop, the screen wasn't that big enough. So you can only see the top of the other board. And then now that I'm going to drag it, it's like, hey, presto, you can see the task is updating in the other browser as well. And that's actually all these round trips between my hotel room in Stockholm and the server running in US West 1. OK, and then one other thing, right? Yeah, because one really natural consequence of using event sourcing is that you have the task history. Or for any business entity, you've got its complete history. And so it makes it trivial to just show the history of each task. In other words, who did what and when, because you just basically grab the events and instead of folding them to reconstruct the current state, you can just display them like that. So you get this sort of built-in audit logging, which is super cool. Anyhow, so that's my talk. So kind of in summary, which may or may not represent entirely what I said today. So microservices aren't a silver bullet, but I think if you're building a large, complex application, they're generally your best choice. For a bunch of reasons that I only kind of touched on, you should really you end up having to use an event-driven architecture in order to maintain data consistency across your services. Event sourcing is a really good way to implement an event-driven architecture, and you almost always have to use CQRS in conjunction with event sourcing because the event store itself is not very queryable. So events plus CQRS in a way is actually really, really good because it gives you these highly tuned views that are designed to support queries very, very efficiently. And then just use a programming model that sort of fits your language and your framework. So just pick the flavor of API that sort of suits the style in which, and the language and the framework that you're used to programming in. So that's my talk. Thanks for listening. Hope that you found it useful. And you got my Twitter, email, and then if you want to know more, there's that form you can fill in. So thank you.
We have questions. Front?
Excuse me. This seems like a very significant amount of complexity to deal with the fact that we're not sharing a database. Can you review why it's so beneficial to not share a database and thus it's worth paying this price?
Please repeat the question.
Oh, yeah. So this seems like an awful lot of complexity to solve the problem where the underlying root cause of the complexity is not sharing a database. So, I think one of the primary benefits of using microservices is to go fast, right? So in other words, your application consists of n microservices, and ideally you want to be able to develop, deploy, and scale each of those microservices independently and in parallel, right? So that's the goal. Now the trouble that if they end up sharing a database, so one immediate problem that you run into is that there's coupling, right? So imagine that, say the customer, let's say the order service accessed the customer table because it needed the credit limit. That would mean that if any time the team that was working on the customer service wanted to change their database schema, they then have to go talk to the team all of the teams that were accessing their tables, right? So that kind of communication and coordination that would result from that will slow you down quite a bit. So basically, coupling slows you down. I mean, you could say that it's this continuum, right? But I mean, I've visited companies where they have lost track of who has been accessing each table, right? And then you can never change anything because you're afraid it's going to break, right? And then on top of that, you can easily end up in a situation where different services have very different data requirements, right? We're sort of moving away from the relational model to the one ring that rules them all to a polyglot persistence architecture where different database access requirements lead you to pick a different database. So that's sort of that's the polyglot persistence argument, the right tool for the right job. Yeah.
So it was so inspiring. I just like copied some ideas to my coworkers already. But
Cool.
That's not the question.
I'm available for consulting and training, by the way.
But my question is this: so the word monolith was kind of like looming somewhere like behind all the time. Was it your intention never to say the word monolith?
Oh, yeah, was it my intention to never say the word monolith? No, I mean, like, you know, in another version of this talk, I go into great depth about why a lot of the time the monolithic architecture is really good, right? I mean, so much about it is really, really simple. The trouble is, it just gets, it's almost like this inevitability that you will get to a point where your monolith is a big ball of mud and your life as a developer will suck, right? But in the interest of time, I skipped over that whole argument. But you know, it really, a monolithic architecture is not an anti-pattern. It is a perfectly legitimate choice. But whether it's a good choice in your situation really does depend on the specifics. Yeah.
So sort of going back to the first question, talking about kind of decoupling and the complexity of decoupling, how much code reuse on an average project do you look at in terms of your data models themselves? Like, I'm sure that there's like a normal pattern is to have data models as a library that are dependent on the different things, but like, where do you know to cut off?
Yeah. Got to remember the question. Yeah, no, it's sort of like what's the level of reuse that of data models that you could expect between services? Yeah, that's really interesting. I mean, I sort of at a higher level. I mean, another topic I didn't go into, right? But another really key thing to think about is the concept of a domain-driven design bounded context, right? So what that effectively means is that, you know, in practice, well, we like to think about having an enterprise-wide model, right, where there is a universal view of a customer. Now, if you try that, your customer table will have hundreds of attributes, right? And it's really complex. And in practice, different parts of your organization, if you even just take something as simple as a customer, different parts of the organization will have a very different view of what a customer is, right? Like, you know, like accounting has a financial view of a customer. So that's all to do with money. Whereas customer support has a sort of, you know, a support-related view of a customer. They're basically a collection of tickets, right? And then marketing will have another view, and sales will have another view. And yeah, they're going to have some attributes in common, like the primary key and the name, but they're likely to be wildly divergent anyway. So that, you know, those are all examples of like bounded context. And so, you know, which is a really important kind of mech tool for designing your services. I mean, you know, the book Domain-Driven Design, it came out in 2003. That book is fantastic. 13 years later, it's full of advice on how to design basically microservice architectures, right? Who would have thought? Because it's not only like strategic DDD, like bounded context, but also the tactical patterns like aggregate are absolutely essential, which I kind of sprinkled throughout my talk. But aggregates are a really essential part of designing business logic in a microservice architecture. I mean, those are the things that are persisted in the event store. So go buy and read. Important to just read it as well, not just buy it. Domain-Driven Design, and then the Implementing Domain-Driven Design book as well. I can't see you. You're behind a pillar.
All right. So one key benefit is the audit log and the event like record storage and storage is Git for free, right?
Yeah. Oh.
What do you think on, well, not exactly free, but what do you think about the possibility on the view side of having persistent references to previous versions of other resources, or the resource be available if that is a useful use case?
Yeah. So the question is, what about on the view side, actually sort of storing historical state and exposing that? Is that kind of, yeah. So, I mean, I guess the answer is yes. If it makes sense in your application, then that can be a valuable benefit, right? Because the view side is, from its perspective, it's seeing a stream of events. So for a given aggregate, it's seeing a stream of state changes. And so it could very well store some representation of the current, of historical state, as well as, say, the current state as well. And, you know, and that's a perfectly legitimate use case. Actually, at the back.
So I just wanted to check if I understood correctly that the main gist of dealing with transactional consistency was to reduce the serialized events, right? To update the state between the custom, you know, the creation of order. Is that right? So.
Yeah, more or less.
Okay. And so when you have that architecture, you're doing more work to roll up events to get the current state and to process them. So I'm just wondering, like, what kind of patterns do you use to deal with speeding up performance, and then also dealing with fault tolerance? Is there any drops in updates?
Oh. So yeah, so what do you do to deal with performance and fault tolerance in event sourcing? I think that was my rough approximation of your question. So I think one of the key performance things is, if you take something like an order, right, that has a very sort of limited life cycle. You know, let's say there's just 10 events during the lifetime of an order, because it gets created and then it's shipped and maybe it's returned, but that's about it. Whereas if you have a bank account and each debit and credit is an event, you could very well have a bank account for 20 years, which would be an awful lot of debits and credits. And so loading all of those events and replaying them would be quite expensive. And so the solution there is to periodically snapshot. So let's say every n events or every n seconds, you take a snapshot of the current state of the business object. Then when it's time to reload it, you just find the most recent snapshot and find the events that occurred after that snapshot, and basically fold them together, so you never need to go back and process 20 years worth of events.
And then, as far as, so what kind of messaging?
Oh yeah, let me just finish up we can talk offline. So yeah, the reliability is, yeah, you want to have a super reliable messaging infrastructure. So that guarantees, you know, where it has to guarantee at least once delivery. So that's my answer, and I have to get off this virtual stage now.
Can we hear it again from Chris Richards?
Thank you.